capacity. And this is really an opportunity cost for your company, for your business. This is demand which cannot be met and cannot be met quickly with this sort of traditionally planned infrastructure, capacity-based modeling. With elastic capacity, what you can do is you can more accurately mirror your capacity against your demand. So we can provision new services, new storage, new servers from the Amazon Web Service platform to you as quickly as possible. So you can keep up with demand as it rises, and you pay a little bit more for that as and when you need it. Up until that point, there's no spend. But just as importantly, when demand decreases, be that for a day or a month, you can reduce the amount of capacity for your service, and you get an associated cost saving with that. So this elastic, bounded capacity is very, very powerful. Moving on from my sort of toy graph, this is the real graph of usage from a real customer. These guys are Monte Carlo financial service simulations. And you can see here exactly what I'm talking about. So we have the number of cores that they're using, the number of CPUs along the y-axis there, and we have time running from March through to the beginning, middle of April along the x-axis. And you can see just how spiky these usage is as they run their simulations. So everybody comes into work in the morning, they run their simulations, and they provision only the infrastructure that they need to run those tasks, to do that work as and when they need them. So you get these spikes in usage around lunchtime when everyone's hard at work, but then when everybody goes home in the evening, they can collapse down, remove that infrastructure, and they're no longer paying for it. So they can move away from having to pay, maintain, power all this infrastructure, all this heavy lifting, towards a much more flexible, agile approach. And really for me, the technology behind this is all very impressive, but for me, the real benefit of cloud computing comes out of agility. It comes out of the agility for individual developers and system administrators to be able to have access to the resources that they need as soon as they need them. They can have an idea over coffee in the morning and have everything that they need up and running for a prototype by lunchtime. It really is that quick. And this sort of developer administrator agility translates immediately into business agility. It means that you can address new customers, build new services much more quickly, and you get the sort of flexibility and agility that is needed for successful business. It's much faster to prototype new ideas, as I say. It's much cheaper as well because you can prototype ideas without having large capital expenditure to fund those prototypes. And if that prototype is successful and you want to launch it into a product, of course you're already deployed against Amazon's global production service. So it's much easier to take those prototypes, scale them up, and architect them for cloud use and for large-scale production use. Of course, all of this is much easier to maintain because we take on the responsibility of maintaining the servers, making sure they're up, cooling, powering, securing all the data. And it's very, very flexible. So you get huge amounts of flexibility in terms of which of our services you want to use. The services are designed to work together, but you can use and pick and choose whichever ones make sense to you. So you could use our storage service, our simple storage service, S3, without using our compute service. You can use our middleware services or our database services without using our compute. Or if you want, you can use them all together in a flexible system. It's very, very easy to integrate and automate all of these services. So as our name suggests, all of these services are available by agnostic standard web services. This is all done over HTTP. We have well-documented, well-maintained, stable application programming interfaces. And there are a large number of software development kits, either maintained by us for things like PHP, or maintained by the community in open source projects for other languages such as Ruby, which provide language level abstractions away from our services. So rather than having to deal with the low level HTTP services, you can deal with the objects and the APIs that you're familiar with the language that you're already working with. So again, this plays into the sort of developer productivity role where developers don't need to learn how to work with a whole new type of database. They don't need to learn a whole new platform. There's just a few simple API calls which they can make to spin up new instances and provision new resources, And of course, you can automate all of this, either for testing, production, or scaling as you move into production, because it's all just automatable. It's all scriptable, and it's all driven through the API. So it's very, very powerful tools to get up and running. Last but not least, of course, it's extraordinarily cost-effective. So in addition to not having to cool and power and light your own data center, you get the cost benefits of the elastic capacity that I talked about. We have a number of different ways of making these resources available to you and charging for them. We do charge for everything, and at the end of the month, if you've only used 1 cent of service, we really will bill you 1 cent. All of those pennies soon add up. So we have on-demand pricing, which is our sort of standard best efforts capacity. But if you have an idea of the amount of capacity that you're going to need over a longer period of time, or if your service is designed to run 24/7, you can actually reserve capacity on the Amazon cloud ahead of schedule, so for a year or up to 3 years in advance. And that allows us to optimize our own capacity planning. And so because we're very focused on customer costs in general, because that allows us to operate more efficiently, we pass on those savings. Between a third and 60% if you reserve that capacity up ahead of time. And like any other data center, we ourselves have excess capacity. We've got very, very large data centers, so we have excess capacity. And we recompute the value of that capacity, depending on how much we've got, as a spot price once an hour. And you can bid against that spot price to have very, very low-cost compute available to you. This is great for tasks which are not time-sensitive, but which you still need significant capacity for. So you can get very, very large savings on that, and there's more of our information available on all of that and our current costings up on our website. So that's a sort of gentle introduction to the sort of core common characteristics of all of our services. But now I want to get a bit more specific and talk about our compute cloud specifically. So as I say, we have a pretty flexible spectrum of services. I'm not even going to try and get through them all today. When I used to give these talks a couple of years ago, I used to be able to run through the services that we have available in about 20 minutes. I could do a good job in that. Now I find it difficult to get through in sort of a 2-hour workshop. Here they all are in a nice spectrum. You can see they all have these slightly awkward acronyms. So S3 is our simple storage service. SQS is our simple queue service. Simple notification service there. EC2, our Elastic Compute Cloud, is what I'm going to take some time in describing today. We also have CloudWatch, which I'll talk about today, and the Virtual Private Cloud, which I'll mention as well. So I'm not going to try and get to all of these. What I want to sort of shine a spotlight on is our Elastic Compute Cloud service. It's one of our most popular services, shortened to the acronym EC2. So this is a service which makes available virtual servers. So we have large racks of servers in our data centers. I'll talk a little bit about their location and how we manage those in a little while. We have very, very large racks of servers. And what EC2 allows you to do is take machine images, we call them Amazon machine images, and take those machine images and instantiate them up on our physical hardware. So you don't need locally, you don't need to co-locate it or anything like that. As and when you need to, you can provision a new server, have it spun up on the Amazon cloud, and have it available just for you. All of this, again, is done on demand. We have a web-based console, which I'll talk and guide through in a second, which allows you to launch these new virtual machines and these new servers as and when you need to. But we also have a suite of command line tools. They all have these EC2 dash prefixes, which allow you to just get down and dirty on the command line or right down, as I say, to the HTTP level of the web services to execute and run new instances, spin up brand new servers up on the cloud. We support both Linux and Windows servers. So a Linux server we can make available in around 20 seconds. Windows servers take a little bit longer because we have to shuttle security certificates backwards and forwards, but still they can be available in the minutes time scale. We've got a fine-grained level of security and access control around this, which again I'll talk about in a little while. We also provide various different sizes of instance. So this is the physical hardware which your virtual machine will run against. We start right down with micro instances. These are available for about 2 cents per hour. From there, you can basically add higher memory, more CPU as and when necessary, and you get to pick and choose the instance size which is most applicable for your application. So when you're working in development or you're doing some testing, the cheapest micro instance is absolutely ideal. As you move into production or you have larger databases that you want to run on the cloud, you can start adding more memory for caching. You can start adding more CPU, all the way up to the granddaddy, the largest instance sizes that we offer, which are what we call the cluster compute instances. These are specifically set up for high-performance computing. So these have things like hardware virtualization. We're very specific. These are Intel i7 Nehalem processors. Got a lot of memory on board. They've got a lot of disks to use for scratch. And last week we also introduced that each of these has a GPU. So each one also has available 2 NVIDIA GPUs for very high performance computing. So you can see we have a pretty broad family of these instance sizes. And again, you pay a little bit more for the higher spec, higher memory CPUs, but we start at just 2 cents per hour for the micro instance. You get full administrator access to all of these new instances, all of the virtual machines when they're made available to you. So you have admin access on Windows, and you have full certificate-based root access using Linux. And this means that you can install any services or any software that you want on these new servers as they're spun up. They're exactly like physical servers, except that they're housed up on the cloud. And that means they're extraordinarily flexible. You can run any operating system that you want. You can run any database that you want. We don't prescribe specific databases. You can run everything from SQL Server on Windows through to MySQL. We're also certified for Oracle, enterprise applications and databases. You can choose any web server, and of course any applications on top of that. So if you've got any content management systems or customer relation management, blogs, ERP services, all of that can be run. And in fact, any back office system which is mission critical is an excellent fit for the cloud because you have much more flexibility to build in high availability and fault tolerance because you don't have to have servers just sat there. For that, you can save money by only spinning up those replacement servers as and when you need them, or you can have hot failovers available too. In terms of where our data centers are, I'm very keen to try and get away from the idea that when you're working with the cloud, the term the cloud is pretty murky at best. It sort of inspires this idea that you can sort of lose control, that everything just disappears out of your fingers and out of control, and you don't really know where your data and your servers are. That is absolutely not the case with the services that we provide at Amazon. We have 4 distinct regions of data centers, and EC2 is available in all of them, as is our storage services and our middleware services. We have one over on the West Coast, one on the East Coast of the US. We have a data center in Europe, which is actually in Dublin, and we also have a data center over in Singapore. Now, within each of these geographic regions, we have what we call availability zones. So each region has at least 2. You can see there over on the East Coast that there are 4 availability zones. And each availability zone is made up of 1 or more data centers which are housed in independent buildings. They're on separate flood zones. They're geographically separated. They have redundant power and redundant connectivity, and they're all, of course, highly monitored and managed on the Amazon platform. What this means is that you can take your virtual machines, you can take your storage and your servers and deploy them across multiple availability zones for as high availability as possible. That means should we even lose power just to a single data center, you can have services running in the same region but in a separate availability zone with separate flood zones, separate fault lines, with separate power and separate connectivity to really maintain availability of your application. So this is a very, very powerful tool. And the sort of thing, it's a sort of undifferentiated heavy lifting, very heavy lifting, which you would want to do with computer systems of any size, but which is prohibitive in terms of cost and in terms of getting it set up and running in the first place. This is exactly where we see the sort of value